Let's see the next question in this series, 916. A 1.5 tall boy is standing at some distance from a 30-meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building. Now, these kind of questions again involve drawing the diagram. These are slightly higher level problems compared to the previous 5 questions because this requires application of trigonometry twice. So in these questions, you will be given two scenarios. So you'll be drawing two right angle triangles. You will be getting two trigonometric ratios, maybe most of the time same, but for two different angles. So let's see how we can draw a figure. Okay. Now, I have purposely shown here some extended length because even though, remember, this is the tower and the complete height is 30 meters, but the boy himself is 1.5 meters. So if you consider the triangles, not entire 30 meters will be coming into picture. That 1.5 meters will be subtracted and you will have the remaining 28.5 meters involving in this triangle because the angles are measured from his eyesight, and let's assume that his eyesight is at 1.5 meters from the ground, so that distance will be subtracted. You will not use this complete 30-meter distance. Some distance will be lost because everything is measured not from the exact ground but slightly above from the ground, and that small distance is represented by this small extension which we are showing here, and that is 1.5. So even though this complete building is 30 meters, what we are going to use in this triangle is 30 minus 1.5, that will be 28.5. And why I'm drawing two triangles? Originally the boy was here and he walked towards the tower, towards the tall building. And originally, let's see, originally the angle of elevation of this boy was 30 degrees. And as he walked towards the tower, this arrow represents the direction of his walking. That angle increased to 60 degrees. So originally he was standing here, looked at the top of the building somewhere here. The angle of elevation came out to be 30 degrees. Remember, the angle of elevation is always measured with reference to his eyesight, with reference to ground. And in the subsequent sequence, when he walked certain distance, he again looked at the top of the tower, and that elevation now changed to 60 degrees because now he's looking from the from a location which is closer to the tower. Right? So we have two scenarios. So here we have two right angle triangles, and let's see how we can solve this equation. As I said, this distance is 30 minus 1.5, which is 28.5. So this distance is x. We don't know how much is that distance. Remember, even though we have assumed this distance as x, eventually that's not our final answer. We will be more interested into calculating this arrow, which is the actual amount of walking towards the tall building. But for the time being, because this is closer and this is a part of the smaller right angle triangle, I will be assuming this as x. Remember, this we will consider first the smaller triangle, and then we'll consider the bigger triangle. So for 60 degrees, even for 30 degrees, the opposite side. This is the adjacent side, and this side is hypotenuse, depending upon which triangle you are considering. So now, assuming that tower is at 90 degrees with the ground. So first, this represents the wall. So first we are going to consider this triangle. In this triangle, we are knowing the opposite side. Remember, this is the opposite side directly facing opposite to this 60 degrees, and this is adjacent, and this is hypotenuse. So now we are correlating opposite, that's known, and we want to calculate first the adjacent side, which is unknown. So we are correlating opposite with adjacent. So the trigonometric ratio which we are going to use is opposite over adjacent, which is tangent ratio or tan ratio. So for the smaller triangle, which is shown by the pink color, we are going to write an equation tan of this angle, which is 60 degrees. That is ratio opposite over adjacent. From standard trigonometric ratio, we know that tan of 60 degrees is always root 3. That's the constant value. So we are going to substitute that. Opposite is 28.5 and adjacent is x. Now we can interchange this x and bring it on the left hand side, and we can bring this root 3 over right side. And even though it is the correct answer, since the denominator is an irrational number in square root, we are going to rationalize this by multiplying by root 3 in the denominator as well as in the numerator. So root 3 will become 3, and this will get root 3 extra in the numerator. Now we can simplify 28.5 divided by 3, and that will come out to be 9.5 root 3 meters. And that will be the distance x. Even though we are not directly interested in x, we are going to use this trigonometry one more time for the larger triangle. And in that case, in the second case, we will consider, so let's eliminate this triangle now. Now we are going to consider the bigger triangle. And in this case, the adjacent is not just the x, it is x plus whatever is the walk distance is there. So adjacent is now x plus walk. Opposite is still same, and now the angle is no longer 60 degrees, it is 30 degrees. So we are going to again correlate opposite with adjacent. We are going to write tan, but this time for 30 degrees, and we are going to write tan of 30 degrees is opposite over adjacent. 30 is a standard value, so tan of 30 degrees is 1 over root 3. That has been given in the table. And adjacent is this complete distance, which is x plus walk. Now we have calculated x, and we will substitute that. That's coming up. So now what I suggest is we will substitute this x value, which is 9.3, which we have found out in the first part. And it's a matter of algebraic manipulation. We will do the cross multiplication, 9.5 root 3 plus walk times 1. So we'll cross multiply this, and we'll cross multiply this. So we can write 9 root 3 plus walk times 1, which is this side, and 28.5 root 3, which is this side. Now we can easily calculate the walk distance by transferring this 9.5 root 3 over the other side, and the walk distance will be 28.5 root 3 and minus 9.5 root 3. Now root 3 is same, so that we can take it common, and we can only subtract 28.5 minus 9.5, and your final answer is going to be 19 root 3. This is in terms of meters, the units are meters, and that is the final answer, which is the equivalent distance, how much he walked from this point till this point. In such problems, remember, two scenarios will be given, and you have to use successively trigonometric ratios for two different triangles. Most of the times the ratio will be also same. For example, we use tan and tan in both triangles. Only the angles were different because the person is walking, and because of that the angle of elevation will change.